Today we will understand services in ROS. Particularly in this video, we will be discussing what are services, what are service servers and service clients, what are requests and responses, and what is the difference between services and publisher subscriber, and we will understand services using a Turtlesim simulation package with an example, and then we will write our own service server and service clients. Now let us have an overview of services. Service. What is a service? Service is a node. In case of a Python, it is just a Python script that answers only when it is called. And it provides a two-way communication. That is, a client has to first request, and that's a one-way communication, and then the server will listen to it and then it will give back the response, having a two-way communication. And it needs to have a request and a response. So the client will request to the server and the server will provide the response to the client. That's how the communication works. And then the service has a service name and a particular service name and a service type. And both the client and server should know the service name and service type so as to have a two-way communication between them. And let us see how they are different from publisher and subscriber. Let us discuss the publisher subscriber. So in publisher subscriber, we have two nodes which we have explained in the previous video. If you have not watched it, go back and see the publisher and subscriber. So in this case, the publisher will be continuously publishing a message through a particular topic, and the subscriber will be continuously listening to the message through the same topic, provided they should have the same topic name and topic type. So that's how the communication is one way in publisher subscriber, and it is continuous. Whereas in services, we will have two nodes. One is a server and another is a client. And instead of a topic, we will have a service, which means it has two components, that is request and response. And this is not a continual communication. It is only once. So when the client asks for the request, the server responds and the service ends. So that's how it works. So with an example, in case of the topics over here, we have the topic name and topic type. In case of services, both the node, that is the server, and the client should know the service name and the service type. Then only the communication is possible. Let's understand this with an example. We can consider the service as a Python function, so which takes the inputs and which will give you the output. And in case of publisher subscriber, the topic message, the message type is the same. Since we have one-way communication over here, the request will have a different structure and the response will have a different structure. Over here, the client, if the client wants to know what is the sum of a plus b, then it gives two integers and then it will ask for the request. So the server will take the request, that is two integer values, and then it will do the computation and it will provide just one integer, that is sum over here, as a response to the node, and the client will accept the response and the service ends. So that's how the communication works in services and how it is different from publisher and subscriber, and when to use services and when to use publisher and subscriber. So when we have a communication between two nodes and it is a continuous and it is a one-way communication, then you must use publisher and subscribers. And when the case is not continuous and it is based on the request and the response, where you have to ask something and then to get a response from something, and it is not continuous, then it's a good practice to use services. And now we will see how we can understand this using a practical example Turtlesim, and then create our own nodes for service server and service clients. Navigate to the ROS Humble documentation. In that, go to beginners CLI tools and then understanding services. So we will be using this example of Turtlesim to understand how we can use services and how we can see the different types and all. So for this, this is the description. I would recommend everyone to go and see the details over here, and we will be just following some of the commands over here. So let's open a terminal and type this to have the Turtlesim simulation over here. Now we can see we have a turtle over here. Let's put it on top, and then we can skip this thing, and then let us see what are the services we have. So to see that, ROS2 and then type services press tab, it will autocomplete, and then press double tap to see the other options we have. So we have the option call, list, and type. So let us see. List will give you all the list of services, and the call is used to call the service, where you will be the client in that case. So for now, let's go for the list. So we have this many services we have, which means these are the service names which we have, and they will have their own service types. So for an example, let us go through the spawn. So this is a service which is provided to spawn another turtle in the simulation. So to do so, and one more thing is, instead of doing ROS to service list, if we provide a tag that is -t, then you will see so these are the service names over here, and these are the service names, and these are the service types. So now let us have a look, and in order to call this service, we have to know what is the service type over here. So to know what is there inside, you have to go ROS to interface, show, and then type, copy paste this to see the content of that service. Now the service type has, so this is the request we have as we discussed, and this is the response. So in order to spawn the another terminal to call the service, we have to give the arguments in the request, and the server will give us the name, which is at the moment is not relevant for us, but it will give the name, and then it will spawn the turtle in the simulation. So in order to do that, we have to give the X position of the turtle, Y position of the turtle, the angle of the turtle, and the name, which is optional over here, so as to summon the turtle over here. So let us call the service, and let us see how the service works. So ROS to service, or we can directly go over here for the command. Okay, over here we have the command to spawn the another turtle over here. So ROS to service call, we will call this call service, and this is the service type over here we have, and in double quotes we provide X, Y, theta, and the name over here. So the name is not given, let us give the name, which is optional for now, turtle2. And then when you enter, so what happened actually is, when I call the service, I am the client at the moment, and when I call the service while providing these arguments, the service will take these arguments, and then it spawns the turtle over here. And over here you can see this is the request, and the response over here is as follows, which is the name of the turtle. So that's how the service works. Now let us create our own service server and service client to do the same functionality over here. To create simple service and client in Python, go to ROS Humble documentation. In that, go to beginner client libraries. In that, we have a section that is write a simple service and client Python. So I will be using this to give you a demo of how you can make your own service and client. And once you understand this, you can create your own service and client using your own service files. So let's begin this tutorial over here. So first of all, we have to create a package. Let me navigate to my ROS2 workspace. In SRC, you will create the packages as usual. Over here, we will copy paste this command, so which is used for making the packages. Over here, using ROS to create package. Over here, this is the package name over here. So the extra command over here is, we have the dependencies, that is rclpy, and the important one over here is example interface. So the example interface over here is a package that has the src file, which is as follows. So which has the request A and B, and it has a response sum. So in the next video, we will see how we can create our own src files, and how we can update our package, and then we can use those service files. So in this case, we will be using the srv file provided by the example interface package. So we will copy this command, and then we will paste it to create our package. Now we have the package created, which has the src file as well. So let's open the package using, so this is the package we have. Let us open it with Visual Studio Code to have a better understanding of it. So this is the package we have in src. Now initially it will be really simple. We will first create a service node, and then client node, and then we will add the entry points into setup.py, and then we will see what is inside of this service and the client node. So for that, let us create a file with the name as provided over here. You can give your own custom name. .py file, and then we will copy paste the content over here. Let us make this file executable. Right click, properties, permissions, allow executable files so as to recognize by the package. And now to make client, just copy paste this so that you don't have to make it executable again, and then write a client node. For this, copy paste the name over here, and then copy the code as well for the client, and then we will see how we can do that. And before we understand it, let us add in the setup.py file the console script, and then we can create our we can just build the package, and then we can run the service and as well as the client. So let us understand what is there in it. So on the server side, what we have is RCLP, and we are having importing the node for creating a node. And from the example interfaces, we are and in the src folder we have the service type that is add two ints, which has the content as follows. That is, the request has a and b, which are two integer values, and the response is one integer value, that is sum. So basically we will be sending a request of two numbers, and the server will compute the sum of the two numbers and it will give that as an integer. So that is the basic example we will be trying using this example. So in this we have initialized a node. We will create an instance of this, and then we'll continuously spin the service, and the service will create, this is the name of our node, and it will create a service with the service type and the service name. And on the client side, this two has to be the same in order to have the communication between them. And then we will call this callback function, which will be continuously running. So whenever it has a request, then it will find, so it has the request as well as the response, and from the response dot sum. How we know that it is sum? From the message we have over here as a sum from the service file. So the response has dot sum is equal to request a plus b, so as to find the sum of a and b. We have on the request side we have a and b, two variables, so we will be use that. And then this is just to give you a log on the terminal, and then it will return the response. So whenever a service call, it will take the request from here, it will take these values from the service, from the client, and then it will find the sum and it will return the response to the client. And then this is from the server side, everything from the server side. And now let us look at the client side. So this is the client.py file. Again, it is taking the same service type over here, taking the node, taking the RCLP. And if we see, this is the main function. We will initialize this and we will create an instance of this function. Over here we are creating a client while giving the same as of the service. Over here we will give the same service type and service name, otherwise we cannot have the communication. And then using this wait for service, we will be continuously looping using this while, so that until the service is available, this loop is continuously running. So whenever we know that the service is available, then we will create the instance of a request from this message type, so that the sub.req will have two variables, that is a and b. And then whenever we have this, we will send from here, we will call this send request over here, and we will give the two arguments from the terminal. So that will be taken as a and b over here, and then a and b, and then using this we will call the service while giving the request over here. So this, when you send this message over here, that will go to the service, and the service will compute the sum and it will give the response. The response will be stored over here. So using this, we will be continuously running unless we get a response. So this will be spinning the node unless we get a response. As soon as we get the response, it will return the future result over here, and that result will become over here in response. And this is used just to give you the log in the terminal that the sum of the two numbers is a response.sum, which is given by the server, which is given by the service, and then it will destroy the node. So that's the basic implementation, which is quite simple. And now when we have the understanding of what the things are over here, let us go to our workspace and let us build our workspace and then source it, and then we will run the files and we will see how it performs. Now we have everything set up, and then over here we will scroll down. So in order to first we will run the service over here. So it's just the same as a node. So ROS to run from the package, we will run the service. Now the service will be continuously running over here. Let us open another terminal over here to see the differences. And this is from the client side. From the client side, we are running the client while giving the arguments 2 and 3. And when we run this code, this will request to the server by giving the arguments A and B, and the servers should take A and B over here and give the sum of the two numbers. And then we will run the client. So as soon as we run the client, it will search for the service. As the service available, it will give these numbers to this, and it will take two arguments, that is A and B, and it will give the result back to the client. So the client will take the result and it will show over here. So let us just make certain modification over here, and then first we will run the client. Since the service is not available, the client will be continuously looking for the service over here. Service is not available and it is waiting unless the service is available. And now when I run the service over here, now we have the result over here. So as soon as the service is available, the client sends a request to the service, and service give the feedback, that is as 2 plus 3 which is equal to 5. So that's how the two-way communication happens in the services. That's why we use services when we have to call only once a while, and then that's how we can have the service and client, and that's how we can have the communication. So with this example, it is clear how we can use the client and services, and in the next video we will see how we can make our custom service files, and then how we can as well as the messages for publisher and subscriber, and how we can use them in our package. And we can make our own custom service file, we can for services, and we can make our own custom messages for our publisher subscriber as well, which we will see in the next video. And if you like the content of the video, do like, subscribe the channel and share the videos. Thank you. See you. Bye bye.